This exercise is a beautiful example of how there is not one right answer to a coding question. For this one relatively simple exercise, I will present 4 different solutions. The input of this code should be either a vector or a matrix, so the code should be compatible with both. The output should be a count of all the double values in the input. Let's start with the first approach. This approach lets us walk through the vector and see if we recognize a value. So how does this work? If we look at a value, we have to see whether we have seen this value before. If we did, we have to count it. If not, we have to remember the value so we can compare it to the other values. So let's walk through the values. Remember, pretend you are MATLAB so you can only evaluate one value at a time. The first value is a 1. We haven't seen that before, so let's store it in our memory. The second value is also 1, but now we already know the 1, so we count to 1. The third value is also a 1 and the fourth value as well, so we keep counting. Then we encounter a 2. We haven't seen that before, so we remember it. The same goes for the 3 after, but then a 2 again, so we count. Then comes a 4. This 4 we haven't seen before, so let's remember it, and then the last 2 numbers we know, so we count them. Now you see we have counted to 6, so in the end our final answer is 6 double numbers. When we want to translate this to MATLAB, we can use a counter again, and we've done this tons of times, and also remembering the unique values is not really hard, we can just store them in a vector. The hard question here is when we put this in MATLAB, how do we recognize a number? How can we check whether a number is already present in a vector? MATLAB has a function for this, the any function. This function is able to compare numbers and then give a true or false output. For example, when you have this vector, you can use the any command to ask which values in this vector are smaller than 1. The same way, we can ask whether the numbers we are consulting are present in the vector of the unique numbers. This way, we can compare any number from the input vector to the unique vector, so we know whether we have already remembered this number or not. Let's open a new file to put this in MATLAB. We are going to write a function with 1 output and 1 input. Remember that the function name needs to match the file name. Close it with an end. Then we want our storage vector of unique numbers, which that's short called UNC. And this is an empty vector to begin with. Then in we have a function, so we define the input in the command window, where we say the the name of the function. And then let's use the first vector we have used as an example. The output should be 6, and indeed the output is 6. We can also try it maybe with the vector that is given in the with the matrix that is given in the exercise book. This matrix should return 15 as an output. And when we run it, we indeed get 15. So this method works. Personally, I wouldn't take this approach. The long stretch of ones in the beginning of the vector makes me want to compare a number to the number next to it. However, in the back of the vector, the numbers are all scrambled. Luckily, of course, MATLAB has a function for this. It's called sort, and it sorts the numbers in your vector or matrix on size. So when you use it, you have a vector where all the values are neatly lined up in order. Let's try this a little in MATLAB. If we sort the vector we just got, we indeed see that it sorts the vector. Now let's try it with a matrix, let's say magic 4. Now you see that MATLAB only sorts the columns. That's not what we want. We can fix this, however, if we give the matrix a name and then make the matrix a vector, which we can do like this. Then we can sort the vector. So by first making a matrix, then making it a vector, and then sorting this vector, we can overcome this problem and still solve matrices with this approach. Now we know how to sort both vectors and matrices. We can think how we want to use the sorting to count double numbers. For example, we can take the second value and compare it to the first. When it's the same, we count it. If it's not the same, we don't. We keep continuing this until we went through the whole vector and counted all the double values. Let's also put this in MATLAB. We can open a new file. And as a basis of this file, just use the code from the previous solution. Don't forget to change the function name. We only need the counter, so remove the storage vector. So in case the input is a column vector, we need to define A, which is a column vector of the input, and then sort it using the sort function. We can write this even shorter actually, by just skipping A at all and just immediately putting the sorted of the column vector of the input. Now the whole core we have to change because we now have to start at the second number because we in our for loop we refer to the first number, and we can use length again because we consult the vector. Then we ask if the value we are consulting is the same as the value before the value we are consulting. And if this is the case, the counter counts up. And that's basically it. So let's run this again and see if this works. Little tip, with the arrow up you can recycle a previous command, so you don't have to type the whole vector again. And then when we run it, we get 6. So also this approach works for the vector at least. Now try the matrix. That also gives 15 as an output. So the second approach also works. We can also change this approach a little by, for example, storing the unique values instead of counting the double values. When you then take the total amount of values in your input and subtract the amount of single values, then the amount of double values remain. So for this, we again have to walk through the vector, but this time check whether the value is different than the one before. Keep in mind that you're not able to compare the first value to anything. This value will always be unique, so you can beforehand store that already. Then each next value will be compared to the previous value, and if it's not the same, you store it. In the end, you count how many numbers you've stored and how many numbers you had in total, and by calculating the difference, you can calculate how many double numbers there are. Again, let's open a new MATLAB file. And for this file, we can just copy the previous function because they are very alike. we can now remove the counter and make a unique storage vector. Remember that we have to store the first number of the vector in here, since we are counting from 2. Then we have to say if they're not the same. We do that with the little squiggly sign. And then if that's the case, we store this value in the unique vector. Then at the end of the code, we need to define how many double values there were. And as we previously found, this is the same as the length of the initial vector minus the length of the uniques vector. And then in the end, the output that the function should give is the amount of unique values. So let's try if this works. We can again recycle the values from previous time. So first the vector, and the answer gives 6. And then for the matrix, the answer is 15. So this approach also works. This approach can be simplified even more. What if I told you that MATLAB has a function that automatically constructs this unique vector? This function is called unique. With this function, we can skip the whole for loop we had and immediately count the amount of unique values and subtract it from the amount of values in the initial input. This makes the whole process even easier. We don't even have to sort or whatsoever. Putting this in MATLAB is too easy, but I'm going to show you anyway. So open a new file and copy the previous code, mainly for the function statement actually. And then we simply say the output is the amount of values in the input minus the amount of values in the unique vector. And that's it. So now when we run it, we see that the output for the vector is indeed 6. And for the matrix, it's 15. So of course, this one also works. So now we have seen 4 different ways to solve a problem in MATLAB. They are all different. One is longer than the other, but most importantly, they are all correct. That makes coding even nicer. It doesn't matter how you solve a problem, as long as you solve it right.